All right, welcome to statistics. So we are going to have our quiz review for quiz 3 here. Okay, I'll post it in a couple of places for you. Let's go ahead and share screen so you can see what we're going to be talking about here. Okay, so what we've got, none of that. Okay, so quiz 3. We'll be covering chapter 5 and chapter 6. All right, 4 questions as usual. There's a couple of things you're going to have to know. Okay, so we talked about chapter 5. So I'm not going to promise you that the quiz is going to be in the exact order of the review. Okay, but here we go with what we have here. So question 1, things you're going to have to know for this is you're going to have to know a little bit about probability. Like, what does probabilities have to add up to? Right, all the probabilities have to add up to 1. All the probabilities have to be positive. It has to be at least greater than or equal to 0. Okay, so if it's a probability of 1.1, like, nope, that's a lie. Okay, or if probability is negative 0.2, nope, that's a lie. Okay, they have to be positive and they have to add up to 1. Okay, you have to know inclusion, exclusion rule. Okay, here's the canonical example for inclusion, exclusion rule. If we have a deck of cards, okay, I know different countries can use different cards. Okay, so I know Hungarians have a different deck than Americans do, or the rest of the world. Okay, so it's 4 suits, or four suits, 13 cards per suit. Okay, suit meaning, right, diamond, heart, spade, or club. Okay, so there's an ace through king for each one of these. Okay, ace through king for each one of these. So there are 4 kings in a deck of cards. Okay, king of diamonds, hearts, spades, and clubs. All right. If I ask you what is the probability of drawing a queen or a black card, we'll say spade or club. Okay, the way you're supposed to do this, okay, is how many queens are there in the deck? Well, there's 4 out of 52 cards that are queens. How many cards are black? Well, we have 13 spades and 13 clubs, so we're going to have 26 possible values for that. Now, we counted the queen of clubs and the queen of spades here. We counted the queen of clubs and the queen of spades here. How many cards did we double count? 2 of them. Okay, so we have to take the including all the pieces and then minus their intersection, the and, okay, the intersection. So that's going to be 4 plus 26. Yeah, 13 make 26. So that's going to be 30. 30 minus 2 is 28. Goes to 52. Okay. So you have to know inclusion, exclusion rule. You have to know this little bit about probabilities. Okay. Question 2, expected value. Okay. So you have to know that expected value is equal to the mean. Okay, so when you see that word expected in a statistics quiz, understand that that's a vocabulary word, and that means you should be doing this. You should add up the value of the event times the probability of the event. Okay, so we want the value of the event times the probability of the event. That's the average. Okay, so that's the other thing you have to know. Okay. This I'm pretty adamant on. Okay. and inclusion exclusion rule. So we're going to add up all the pieces we're including, and then we're going to subtract out the parts that we've over counted. Okay. Expected value of the event times the probability of the event equals the mean. I know in this section they asked you a lot about standard deviation. I will not be asking you to calculate a standard deviation. Okay, that's not what we're doing. So just the average. Okay, we'll do a couple of examples for that. And then you have to know how to calculate a binomial probability. Okay, you have to know how to calculate a binomial probability on your calculator. Okay, you could do it by hand if you'd like. Okay, I'll be impressed. But you don't have to do it by hand. You have to be able to use your calculator in order to get to a binomial distribution. Okay, so let's take a look at what we've got. Okay, so we're going to do 5.2, 6.1, and 6.2. Okay, those are the sections that quiz 3 is over. All right, so let's take a look at those. This one. So let me go ahead and get this. We've ended. Great, we've ended, and we're out of here. Okay. So going back a little bit in time here. Okay, let's take a look at something like 5.2, because I think 5.3 was optional. So if you did it, great, that's extra credit. But if you didn't, that's okay too. We're not going to penalize you for that. So let's just do a preview of what we're looking at in 5.2 here, okay? It was going to be toward the end. Actually, I really like tables, and I do not. Oh, there's perfect. There's a table. Okay. So we have following table represents the number of reports of graffiti in each of New York's 5 boroughs over a 1-year period. So we're going to refer to this table every time. Okay, and I've got a problem that's very similar to this for your quiz. Okay, so I like tables because you can see everything that you would like to see for it. Okay. All right. So what is the probability the report is open and comes from Staten Island? Okay, and in statistics means intersect. Okay, it's this intersection. Okay, so they want an open report from Staten Island. An open report and comes from Staten Island. So here's my Staten Islands. Here's my open report. So you look down, look across. It is literally the intersection of these two, the row and the column on the table. That's 83 over the total. Okay, so we're going to have 83 over, okay, 14,518. Okay, I don't like numbers this big, so I made them smaller. On your exam, on your quiz rather, you could leave it like this. I would prefer it. Okay, or you could, if you wanted to go through and say, well, I like decimals more than fractions. Okay, so that's 83 divided by 14,518. Okay, and you would write this down to 4 decimal places, 0.0057. Okay, and that's how we would report our answer. Okay, so that's what we would have there. All right. Next one is closed or comes from the Bronx. Okay, how are we supposed to answer this? Okay, is closed or comes from the Bronx. So this is the one that's a little bit tougher. Okay, so we want closed or comes from Bronx. Now this is the key word you're going to know that it's going to be inclusion exclusion. Okay, we'll look at the table and I'll show you why. Okay, so it's closed or comes from the Bronx. So with the or, we got to add up. Okay, we got to add up all the ones from the Bronx. Okay, so that would be this whole line. This would be, let's go slow with this. Let's go with the Bronx is 1121 plus 11 or 1622 plus 80. Okay, that's what we have. Closed or comes from the Bronx. So we're gonna, this is from the Bronx. And then we're gonna do closed, right? Closed or comes from the Bronx. So the closed are 1622 plus 2706 plus 3380 plus 2043 plus 118. Okay, so that's the closed reports. How many times did we count this one? We counted the intersection twice. We counted it once for the Bronx, we counted it once for the closed reports. We have to take away that 1622. Okay, that's what the inclusion exclusion rule is. Okay, and you got, I asked this pretty much the same format. I got a table, I went through and did this. If you want to go through and piecemeal do this, you are welcome to do that. If that helps you remember it, then do it that way. All right. If you want to remember, it's like, oh, it's this total plus this total minus the intersection. That's fine too. Okay. But either way, we're going to get the right answer out of this. So we're going to have 2823 because that's these things added up. Okay. We're going to have closed reports. So you can look if all of this added up, right? We had what, 9,869 plus 9,869. And then we have to subtract off one of the things that we counted 2 times. Okay, so now we've only counted it 1 time. That's what we want. And of course, we're going to make this a probability because if you tell me it's like a big number, I'm going to say, nope, you're wrong. It's 14,518. Okay, and we're going to go through and calculate that. Okay, but that's how you do that. And again, if you guys want to leave it like this, I don't have a problem with that. Okay, I'd like you to simplify. Okay, especially since my numbers aren't nearly, they're not in the thousands. Okay, I think they're in the hundreds. Okay, some of them are in the tens. 2,823 plus 9,869 minus 1622. Set that equal. That's 110. Oh no, it's not that much. 11,000. What we have 70 over 14,518. By the way, this is going to be your first quiz where you're going to be writing stuff down and then taking a picture of your work and depositing it into the Dropbox that is next to the exam, okay, or next to the quiz. So when you're doing this, try to make your work neater, okay? When you take a picture, try to look at the picture when you're done. Like, can you read that? Because I've had some students who said, you know, I pointed my camera directly into the sun, took a picture. I can't read that. Okay, don't do that to me, please. Okay, or don't go down to your basement and take your picture with the lights off because I won't see that either. Okay, you have to look at your picture and see, can I make out what I've written? Right, that's the goal here, because that's what I'm going to grade. And I really like seeing your train of thought. You know, like if I see this, I'm going to think, oh, I know what you did. You got your totals here, your totals here. You subtracted off the amount you counted twice. You divided. I'm happy. Okay. After you got this, like this is what I want to see. That's what that's what I'm putting a star on. This is nice. Okay. But I really want to see your train of thought. I want to see this part to get to this. So I want to see, where did you get your numbers? All right. So when you get this question like it, and you've written it down like this, that's perfect. That's exactly what I want. Okay. Some of them aren't going to be that involved. Okay. The report comes from Staten Island. Okay. Staten Island. There's 210 of them. Okay. We don't have to worry about anything else. It's just 210 divided by the 14,518. Okay. So that's like that's the major concern for this problem. Okay. So this was 5.2. It was number 10. Okay. Anything that's got a table. Okay. I try to keep it so it's not like a 30 by 30 kind of a monstrosity. Okay. At worst, it's like a 3 by 3. You know, where you've got 3 boroughs and then 3 categories, right? Or 3 age groups and 3 types of music, something like that. Okay, that's the worst it usually gets. All right, so that's the idea for inclusion exclusion rule, and part of our probabilities, right? Because you give me a number that's bigger than 1, like, it's wrong. Okay. If you put the percent after it, I will take that, but you have to remember to put a percent after it. Okay, that's fine, because at this point, right, everybody asks, like, percent or decimals? Okay, here's my question for you. I have 50 cents. I have 2 quarters. Do I have 50 cents or do I have 50% of $1? Do you really want to argue about that? I don't. So that's how I feel about percentage. They're equivalent. So if you want the percent house, go for it. Okay. So that is the kind of thing I'm going to ask you for this one. Okay. Let's take another look at what else we've got. Okay. So inclusion, exclusion rule, some probabilities. All right. I'm not promising you that every problem we're going to do here is going to be on your quiz, and I'm not promising that all your quiz will be completely inclusive of what's going on here. All right. So next one up. I don't want videos. I'm not doing videos. I want stuff. I don't capture videos, by the way. If they're helping, great, watch them. If they're not helping, you cannot watch them. Okay. So again, okay, let's take a look at this one. Okay, the last 3 problems in this section are all 4 questions. Yeah, these are all expected value problems. Okay. Yeah, these are all expected value problems. Anything, actually all of them are expected value problems, but of course, statistics, we have to have a story attached to it. So anything 6, 7, 8, 9, and 10, these would all be good choices. Okay, let's go ahead and look at 10 first, then we'll look at 7. Okay, so we have an insurance policy. Your insurance company sells a 1-year term life policy to a 78-year-old woman. This woman pays a premium of $3,300. If she dies within 1 year, the company will pay her $54,000. We'll pay her beneficiary. She's not going to be alive to collect it. Okay, and then we have a probability that this person is alive 1 year later is 0.9398. And let's figure out the expected value for the insurance company. I don't ask you like parts A for this and parts B. You set it up however you want to set it up. Okay, but again, grading you on how did you get to your answer. Okay, an answer is not enough. You have to show me how that happened. Okay, you're going to have 2 kinds of bosses when you leave school. You're going to have the bosses like, I need the answer. You think it's good? We're done. But in a bigger company, you're going to have somebody like, walk me through this. How did you do it? Okay, so I'm more of a walk me through it type of a person. Okay, so let's see here. Let's see if she gets to celebrate her 79th birthday. Okay, so okay, so the value of the event. Okay, if she lives, she's out $3,300. Okay, if she doesn't live, well, she's out everything, but her heirs, right? They get the $5,400, but she doesn't have that $3,300 in her bank account anymore. Okay, so that's going to be $5,700. Okay, I think we'll be able to say that's 54. Yeah. So the value of the event, if she doesn't live, to her heirs, okay, is going to be plus 50,700. Okay. So that's our X. What's our probability? What's the probability of this happening? So by US CDC, okay, the chance for her to be alive is 0.9398. Okay. What's the chance for other things to happen, right? We're going to take 1 minus 0.9398. Okay. So you can plug that in the calculator, right? 1 minus, nope, not that. 1 minus 0.9398, right? And that was 0.0602. So just got a 6% chance to die. 0.0602. Okay. And then I'm going to erase this stuff here. So I need that room. I should have managed better. And if you want to do this horizontal, that's fine. You want to do it vertical, that's fine. It doesn't matter. Okay, as long as you line up your value of an event and the probability of an event. You could line them up as rows or columns, doesn't matter. Okay, so the next column I'm going to have is x times p of x. We're going to multiply these two columns together. That's why I put the negative in here, is because I want a negative value to come out of my expected value here. Okay, so this is value of the event times the probability of that event happening. Okay, when I was younger, I used to play a game with like baseball cards, and I thought I invented this. Okay, we used to play a game with baseball cards, and we'd roll 3 dice, and we consult the card, the player. And most players, well, not most, but a lot of players had like they had a really good chance of getting a single on like a 9, 10, 11, 12 kind of roll. Okay, maybe it's 2 dice. So 6, 7, 8. Okay, they did pretty well. Yeah, it had to have been 2 dice because the Monopoly came with 2 dice. Okay. But my friends really liked the players who, if you rolled like a 2 or a 12, you got a home run, triple or something. They like the big numbers. And when I started trading them, okay, I started winning. Because I would say, oh, I did not, as a 12-year-old, I did not say this. Like, the probability of getting a 6 or a 7 or an 8 is high, but you get low values, but they add up. Okay. 0.6002. Okay. So they accused me of cheating because they started losing. Okay. Oh, this is not a good thing for them. Okay. So negative 3,300, and the probability for that, negative 3,134, this is a little bit bigger. So the expected value for they're losing money on this. That can't happen. Insurance companies don't win. It's like casinos. Casinos don't lose money. Okay. They don't build the pretty buildings for losing money. That's not what they do. Insurance companies got really big buildings in New York. They ain't losing money. Okay. So they're taking a loss. Negative 49.2. Okay. Did I mess up? 54,000 minus 3,300. Like, it's so unusual that they would lose money. I'm actually questioning everything I've done up to this point. Okay. That shouldn't happen. 5,700, we're good. And then the other one was okay. So yeah, in this case, they're losing money on this one. Okay. So X is going to be, we would have paid, oh, sorry. I was doing it from the point of view of the woman. That's not good. Okay. So I did it incorrectly. So I'm glad I was thinking about double checking it, because that's not good. Okay. So where's my little thing here? So yeah, sorry about that. I went backwards. If she lives, they pocket the $3,300. If she dies, well, they're not giving that $3,300 back, but they do have to shell out $54,000. So that's I got the signs wrong. So this one should be a negative. This one should be a positive. This should be a positive. Okay, all is right with the universe. The insurance companies are now making money. We could be happy. Okay, so they study this stuff. They know. Okay. That's why we have a CDC. It's where insurance companies can make money. Okay. Well, not really, but that's why we have these tables here. Okay. So there we go. That's they make $49.20. Okay, and here 3,300. Okay, that's their profit. Okay, and oh, the P of X. What am I doing? P of X. If she lives, probability 0.9398. Okay. Probability should not live 0.0602, I believe. Okay. And then we're gonna have to multiply these together and do all of that. Okay. Didn't like that. What did I do? Oh, 700. Okay, that might be better. All right. Check. So yeah, they went to leading zeros. Okay. Expected profit. There we go. $49.20. 49 dot to 20. This is also why it's really important to write this stuff down, because you can see like, well, what if I didn't write down the right number? And I just gave you a number at the end. I said, well, that's wrong, but I got nothing to check it against. So it's right or it's wrong. Flip a coin. So again, you want to build something like this and show me your calculations so I can see what you're doing. So if you did pull a boneheaded move, like make this a 7 instead, then I can say, oh, that's transposition error. That's a different kind of mistake than not knowing what you're doing. Okay. So enough of that. But that is expected value. Okay. Let's go on to a different one. Let's do the New York lottery. So what is the expected value of your profit? Okay, so that's what we want, is our side. Okay, so now, I mean, for the New York people, it's going to, for the lottery, it's going to be the opposite. Okay, so in New York State, the numbers lottery, you pay $3 and bet that the sum will come up with 13. We don't really care. Probability of winning is 0.08. If you win $6.50. Hooray. Profit of $3.50. If you lose $3. Okay, what are we doing? So X and then P of X. Okay, the value of the event. Hey, I paid $3. Okay. And we have a profit of 3.5 if we win. Okay, so this is a loss. This is a win. Okay, what's the probability of winning? 0.08. Okay. Now, when I was little, milk for lunch was 8 cents. If you put your dollar down, right? 8 cents, put a dollar down. What is the change you get from a dollar if something costs 8 cents? 92. Okay. And then we're going to say value of the event times probability of the event. All right. Multiply these across. Okay. So -3, -3 times 0.92. Okay, -2.76. And 3.5 times 0.08. Okay, 28 cents. When I add these together, okay, so we have -2.76 plus 0.28, and we end up with -2.48. Okay, your profit for paying the lottery, right, is you're losing $2.48. All right, New York is making $2.48 for everybody who plays this lottery game. Okay, expected value, negative 2.48. There we go. Okay, is it expected gain or expected loss? You are losing money. Okay, so it's a loss of $2.48. I'm not going to ask you to follow up. I'm just going to ask you what the profit is. All right, that kind of a thing. Again, I really am interested in seeing you come up with a table like this and then going ahead and calculating what's going on here. Okay, so I really want to see the calculation. I really want to see the X and the P of X setup. I want to see all that. Okay, next. Okay, so that was expected value. That was 6.1. 6.2. Preview. Start. Come on. All right. There's always going to be a word problem. Okay. Almost always going to be a word problem. I don't like giving non-word problems. Okay. Reasonable. I don't quite like the wording on that one, but because I don't like the success being failing a test. That sounds weird. People have a problem with it. This one, however, good problem. Okay, study conducted. 57% of cell phone users use their phones inside of a store for guidance on purchasing decisions. Okay, either reading reviews, looking for other prices, whatever. We have a sample of 14 cell phone owners. Round answers to at least 4 decimal places. Same deal. What is the probability that 6 or more of them use their phones on purchasing decisions? Okay, so let's write down. We have n is equal to 14. Probability of success is that they use them to check. So that would be 0.57. Okay, and then here we have more than 6, or 6 or more rather, 6 or more. What numbers are 6 or more in the context of this problem? Well, 6, 7, 8, all the way up to 14. So this is a collection of numbers. So we're going to do 1 minus. It's more than. Okay, binomial CDF, right? CDF is cumulative distribution function. It goes from 0 up to a certain value. What value are we going to go up to? We're going to go up to 5. Okay, so we've got 14 people. We have a chance of 0.57, and we are going up to 14 people. If we take the complement of this, this will be the probability for 6, 7, 8, 9, up to 14. That's exactly what we want. Okay, so we're going to go to our calculator here, and we're going to say, okay, 1 minus, okay, second function distributions, okay, binomial CDF, this one, okay, and so this, when you're doing a problem like this is what I want to see. I don't want you to just spit out a number at me. I want you to see, what did you think this was? Did you put these in the right order? Okay, if you have a TA84, you don't have to memorize the order. If you have a TA83, you got to memorize the order. Okay, you can get TA84s from the C&M library, okay, for a couple of hours. You can check them out. Okay, so we have 14, comma, 0.57, okay, and then 5. Okay, we got 0.90. What do we have? 9090. All right, so that's how you do that kind of a problem. Okay, and I promise you there is a problem like that on your quiz. So you don't have to know the formula for it. I'm not asking you, okay? But you do have to know, how do you plug these numbers into your calculator and get an answer? Okay, I didn't ask nearly this many. Okay, I asked 3. All right, part D is not too bad. I didn't ask this kind of thing either. So, okay, that fewer than 10. Okay, fewer than, what is fewer than 10? What does that mean? Okay, if you say your child, you may have, we're going to go to the store, you can pick out what you want, but you have to have fewer than 3 toys. And the child picks 3 toys. What was your instructions? Is the 3 they picked fewer than the 3 that you set? No. So when they say fewer than 10, they mean 1, 2, 3, up to 9. 10 is not fewer than 10. So we want binomial CDF up to 9. Do I have to put the 1 minus here? No, because it didn't say more than. Okay, so we went from 0 to 9. That's fine. There's 14, success, 0.57, and we're just going to type this in. Okay, so we're going to say distribution, so second function distribution. We're going to go down to binomial CDF. Okay, and then we're going to say 14, comma, 0.57, 0.57, comma, up to 9. Okay, 10 or fewer. Was it 10 or fewer? Or is it fewer than 10? What do they say? English is always the problem. Fewer than 10. 10 is not included. Okay. Plug that in, plug this in. Again, this is what I would want to see. Okay, so when you're doing your exam, you're doing your quiz, I want to see part B, and then type this out, and then equals. Okay. Okay, and 0.97922. 7922. Okay. 0.7922. Okay, I don't really take off for a weird rounding. So if you round, I mean, that's why I say 4 so that everybody's got a common place to go with, but I don't take off of rounding. So if you didn't round it correctly, that is literally the least of your worries. Okay. I don't add it to 0.8 because I want to see something here. But if you didn't round the last, that's why I asked for 4, is because 3 of them were right. Okay, that way I can tell. Exactly 8. Okay, so this is a binomial PDF. Okay, it's called probability density function. I will not be asking you that. You can think of it as a particular number. The binomial PDF is for a particular number. So 14.57, and they said exactly 8. 8. Okay, that's what we want. So when you see a particular number like none, that's particularly 0. Okay, or all, that's 14. Okay, so that's how we calculate that. Okay, if you see a particular number, x equals exactly this, it's a PDF rather than a collection, the CDF cumulative. Okay, so equals, and then we'll just plug that in and we'll go from there. So that's going to be second function distribution. Okay. Binomial PDF because it's for one value, and we have 14, oops, not 144, 14, comma, 0.57, okay, and then 8. Okay. So 0.222115. Okay. And that's how you do with the binomial stuff. I'm not going to ask you unusual. It's kind of a silly question, but there's less than 0.5%. It's less than 5%, then it's unusual. That's all they mean. Okay, so I'm not going to ask you that. But these something like this is exactly what I would ask you. Okay, so for chapter 6, right? Turn to the spots where they have a story problem. Chance those. And see how well we can do with that. Okay. So again, I will not be asking you the average. So you don't have to know NP. I will not be asking you standard deviation. You do not need to know that formula. You just need to know how to calculate these probabilities inside of your calculators. I will not be asking you about the formula at all. Okay. So don't try to go nuts trying to memorize everything. Okay. Be able to do this in your calculator, be able to do expected value, be able to do inclusion, exclusion, and know that probabilities have to add up to 1 and that they can't be negative. Okay, so try to keep the amount of things you have to memorize to a minimum. Okay, that's a bit. So we're going to stop that here. I'm going to go ahead and release the quiz, and good luck.